Here I am I'm still in section 9.3. We're going through the learning outcomes from your lecture study guide. And here we are on identify some heavy metal control agents and describe how they are used. So heavy metals are really toxic. These are things that you only need very small concentrations, and we know heavy metal accumulation in any living organism, including humans, can be very toxic and cause nerve damage and brain damage. So, but they are effective microbial control agents. They're giving you some examples of some of the heavy metals that are used. Mercury you might find in some paints. Mercury used to be used a lot more. What is it called? Thimerosal. Oh, I'm hopefully not messing up the name, but that the preservative that was in a lot of vaccines was a mercury-containing compound, and it got a reputation for causing autism. Well, now we know it absolutely doesn't cause autism, but it was a preservative that was used in vaccines frequently. It's been taken out of most vaccines and maybe all vaccines. I know it still is in some cosmetics and all, but apparently it's not supposed to be harmful in the concentrations or in the formulation that it's used. But mercury isn't used as often for microbial control as it used to be. One that's a lot more common than it used to be, that's used a lot more than it used to be, is silver. And so silver and many other heavy metals have antimicrobial properties. I like to point out a couple of the ways that we've been doing silver. Here, let's look here. Preservatives as cosmetics, ophthalmic solutions. When babies were born in my generation, they used to put drops of silver nitrate in their eyes, and to prevent the picking up any infections as they were being born, specifically different eye infections that could cause all sorts of problems. So when babies are born, they put antibiotics in their eyes, same thing. But what they would do is they put silver nitrate, and silver nitrate is actually in these bandages. It's this black color. And what you can do is put silver nitrate in bandages. And in this case, maybe it looks like the person has some kind of burn. And you can imagine all that dead tissue is great food. It's warm, it's moist, it's a great place for bacteria to grow. So if you can wrap these kinds of wounds in bandages that have silver nitrate in them, it can actually prevent the microbial control in the tissue and the associated bandages. You can actually buy Band-Aids that have silver nitrate in the pad to be an antimicrobial. And here's another one that's called Silvadene cream. And again, it's really common to use for burns or wounds that resemble burns, like brush burns. And one of the main reasons why Silvadene and silver is being used a lot more on burns is it actually has been shown to speed wound healing. We said in the previous video that hydrogen peroxide has been shown to slow wound healing, but silver has actually been shown to speed wound healing, and so it is being used topically. You can see here it can be toxic if inhaled or ingested, but we're using this mostly in topical creams, and that's not doesn't have those complications. So silver is one heavy metal that it's used in very low concentrations, but it's been an effective antimicrobial. The next chemical I want to talk about says discuss the advantages and disadvantages of using aldehydes and describe how they are used for microbial control. Now you might remember hearing about aldehydes in a class, organic chemistry class you took. And the aldehyde group, it was one of those organic side groups that lots of molecules have. And the aldehyde group is really unstable. So aldehydes, the chemicals that have aldehyde groups, tend to kind of bump around in cells, and whatever molecule they interact with, they damage. So they're very damaging to DNA and to proteins and to cells in general. And because of this, aldehydes can kill endospores. And that means, again, they're a high-level germicide. They can sterilize. These are not chemicals that you're going to have around your home because they're very powerful. Probably the one that you're most familiar with is formaldehyde. And here's a picture from the Civil War of somebody being embalmed with formaldehyde. And this chemical, it preserves the tissue. It prevents the growth of microorganisms. And so they could take a deceased body and bring it, have it shipped back home so people could bury them at home. And so this was a time when they commonly started doing this. We still do a lot of embalming in the whole mortuary industry and funeral home industry, and it preserves the tissue. Some people are saying, do we really need to use these powerful chemicals anymore? To do that, maybe we should find other ways to deal with embalming or treating our dead bodies. Formaldehyde is still used, but there's other things that they use in addition to formaldehyde, another aldehyde called glutaraldehyde, and they also put a lot of alcohols, particularly methanol, in the preserving fluids. But formaldehyde is really a potent chemical, and it can be dangerous to handle. The one that's used more often, and it's a little bit less toxic, is something called glutaraldehyde. But that also, it's toxic, but not as bad as formaldehyde. Here it says glutaraldehyde can be used to sterilize respiratory equipment, scopes, kidney dialysis machines, dental instruments. This is a product that you might see in a clinical setting. That's one of the products that contains glutaraldehyde. It's called Sidex. And you wouldn't use Sidex in a regular, let's go clean up the room situation. But if you knew your patient had tuberculosis, or it was something that you're concerned, respiratory equipment, and you could have had, been exposed to bacteria like tuberculosis, which are hard to kill, you might use something like Sidex. So you may use Sidex in a clinical setting, not so much at home, but it can be a very useful product when you need it. The next chemical I want to talk about is alcohol. And again, alcohol is one of those we have at home. It's definitely a low-level germicide. Here it says it kills most bacteria, viruses, and fungi. So again, depending on how you use it, you might be able to get it, use it as an intermediate level germicide. But mostly what we're doing is using it as a low level. The common one we use in microbial control is isopropyl alcohol, although methanol and ethanol work quite well too. Here we have the concentrations, let's see, it's germicidal, it's non-irritating, it's inexpensive, it works great on skin. One of the things about alcohol, though, is that it evaporates really quickly. The rate of evaporation decreases effectiveness. Now, one of the things that's really common with the use of alcohol is something we call degerming. And alcohol dissolves cell membranes. It says compromises membrane integrity. And they're lipids. And so what alcohol is really good at is dissolving lipids. So when you're going to give someone an injection, what we do is we do a degerming procedure where you take an alcohol swab and you wipe, usually in a circular fashion, from the center out and with the alcohol. And that's not necessarily killing the bacteria because it's there for such a short amount of time. But what it's doing is breaking up the oils, and it's pushing the bacteria to the edges of away from where you're going to make the injection. So you're reducing the number of bacteria in that area. So the alcohol can kill bacteria, and we know that from like hand sanitizers on our hands. Hand sanitizers have that gel-like solution in them because it prevents the alcohol from drying so fast and keeps it in contact with your skin long enough to do some microbial control. Okay, but alcohol is an effective antiseptic, and it's used routinely. I just stuck this in here. It says alcohol-based hand sanitizers are the mainstay of disinfection of surfaces, and antisepsis of hands during the COVID-19 pandemic. Remember, SARS-CoV-2 is an enveloped virus, and envelopes are more susceptible to detergents and alcohol. So we used a lot of alcohol in those days, and we're still using it, right? Okay. Explain how detergents can be used. So there's this, so we use the word soaps, and soaps are generally, they break up oils on the skin. I mentioned this at the beginning of the, I think, section 9.1. But soap breaks up the oils on the skin, but soap itself is not really antimicrobial. It's more of a mechanical action, mechanical removal of microbes. But detergents actually have the possibility to mechanically remove microbes by breaking up oils. We rinse them off, but it also acts as an antimicrobial. And the detergents that we use are called quats. They're called quaternary ammonium compounds. So these are the chemicals that are probably one of the most common antimicrobials in your house that you never heard of. Quats are used all over the place. A lot of the products that we use around the house contain quats. Go look at your like Mr. Clean and Fantastic, and some of the Clorox products, the Clorox wipes, are not actually Clorox. They actually contain quats, detergents. How do I know it's, when I look at the active ingredient, how do I know it's a quat? A quat stands for quaternary ammonium compound. So an ammonium has this nitrogen with 4 groups on it. That makes it a quaternary ammonium. And so if you look at the active ingredient on your label, it's this big long name, and one of them is, here's just an example of one, N-alkyl dimethyl benzyl ammonium. If it says ammonium, it's a quat. And that means it's not only a surfactant, it not only breaks up oil so you can rinse off dirt, but it also is a disinfectant. And so, so a lot of the products we're using are quats / disinfectants. I put right here, do we overuse these disinfectants? How many times would soap just be enough to just rinse away the dirt and the microbes? Do we really need to add more chemicals to disinfect? And there's actually people that talk about reducing our use of quats, because why should we use these chemicals when we don't have to? Let's see, it says they're effective against some bacteria, viruses, and fungi. I would put this at a low-level germicide, but again, it's something that we use in our routinely around the home. Here it says rated as a low-level disinfection. In a clinical setting, it's used. It can be used in restaurant utensils, dairy equipment, surfaces, restrooms. We use them all over the place. It's ineffective against tuberculosis, which actually makes it a low-level germicide. If you could kill tuberculosis, you would probably be an intermediate level. And its activity is greatly reduced in the presence of organic matter. So what that means is if you have a really dirty surface and you're using a quat, it might not be as good at disinfecting as you want it to be, but it will clean up the dirt because it has a surfactant, has soap-like properties in it. So quats / detergents are important low-level germicides that we use all the time. Identify the applications for ethylene oxide. And I have ethylene oxide sterilization. This is not something you would use at home. Ethylene oxide actually is quite dangerous. And it says it actually kills endospores and other gases. And it kills endospores. Any other gases are less effective. The unique thing about ethylene oxide is it's used as a gas. The only other microbial control we talked about that's used as a gas was some forms of chlorine. Chlorine can be used as a gas. Ethylene oxide, like I said, is another one, and it's very effective at killing endospores, so it can sterilize, so it's a high-level germicide. I put a couple pictures here to show you how ethylene oxide is used. This is an Apollo spacecraft when the Apollo astronauts went to the moon or even into outer space. when they came back in this little spacecraft, and nobody knew if there were microorganisms out in space. We hadn't been there. We didn't know if there were microorganisms on the moon or in space. And then you look at this capsule that these people are inside of, there's lots of nooks and crannies, little crevices. And so when they brought these space capsules back, what they did is they sterilized them just in case. The astronauts were actually put into quarantine to make sure they didn't pick up any pathogens. And the space capsules were sterilized using ethylene oxide. So they put it in a chamber, they pumped this gas in there, and it gets in all the spaces, and it sterilized it. And so you can do that when you have, very sensitive equipment and something that can't get wet. You can't put liquids on it or anything like that. The other place where we use ethylene oxide quite frequently is in the healthcare industry. And here, this chamber, they're putting in all these different instruments, the different kinds of plastic syringes, even some of these pre-packaged clothing things, surgical things that you would use. And they put it in this chamber. It looks a lot like an autoclave. You seal the door, and they pump ethylene oxide in it, and it gets into all the crevasses without getting anything wet or leaving any residue. And then they leave it for, a couple hours. They pump it out, and everything's sterile. Now, all this is done in a highly controlled environment because ethylene oxide is explosive. It also is a carcinogen. But these machines are designed to be used without getting anyone exposed to the ethylene oxide. And so they're used frequently in healthcare. Here's a table that's in your book, and you might want to look at it just to show you some of these different things that you might be familiar with and what is their active ingredient. Go look around your house, and it's always interesting to see the active ingredients. The last thing I want to show you is what if we put all these together that we just talked about, what are our high-level germicides? Remember, these are the ones that can kill endospores and therefore sterilize. So if you look down the list that we had, see if you can pick those out. I gave you the answers right here, but remember, most of these aren't used as high-level germicides routinely. Chlorine gas can be used to sterilize, but more often we use chlorine as a disinfectant or an antiseptic. Same thing with iodine and hydrogen peroxide. I would say aldehydes and ethylene oxide are the two that are the most often used as these high-level germicides and are not used in other cases. These are not things you would find in your home because they are very powerful chemicals. On that note, I'm going to say the end to microbial control.